Hey guys, welcome to our subject for today. And right now we will be discussing yung support reaction of beams and also yung internal forces na tinatawag natin. Okay? So, from our previous lecture, we already determined kung ano yung um, stability ng structure natin. Ngayon, once na na-prove natin na determinate yung structure natin using the equilibrium equations, we can calculate yung support reaction natin for the time being. Kasi pag halimbawa indeterminate siya, we cannot use lang yung equilibrium equations. We need another set of equations which are called um, uh, uh, equations o yung gagamit na tayo ng relationship ng deflection and rotation, which is not covered yet at this part ng discussion natin. Okay? So to start with our discussion, here's or the outline of our PowerPoint. We will be discussing yung type of beams natin, and then we also have yung common loading types. Then procedure for solving yung support reactions natin are also given. We also have some sample problems to work out. And then if the time permits, discussion also of the internal forces. Okay. So at the end of the session, here are our takeaways, hopefully. First is to familiarize ourselves with the different types of beam and different loading patterns na available sa beam structure natin, yung pwedeng ma-apply sa kanya, ibig sabihin. Next is to solve different loading conditions to find the support reaction. And last is to describe what are the different internal loadings present in a structural member, especially kapag beam yung pinag-uusapan natin. Okay? So to start, we need to take a review ng mga support natin. No? So from discussion last week, hopefully tanda pa natin to and sana mas matandaan pa natin to longer kasi ito yung lagi natin gagamitin in solving for our support reactions. So we have three categories ng ating supports. So we have yung first category natin which has a one number of unknowns o isang um, resistance, no? Dun sa ating member. So ito yung roller, rocker, tsaka link. So na-identify natin last week na kapag roller and then nakapataw siya sa isang surface, merong naka-perpendicular na resistance o na force directed towards nung mismong structure natin, anong member natin. Also with rocker, kung saan siya nakapatong na surface, nandun din yung reaction niya. And then we have also yung link, kung saan naman yung direction ng link, doon nakadirect yung mismong force natin. So on all of these forces or all of these reactions, support conditions, we only have one unknown reaction. Kasi yun lang yung nire-restrict niyang movement, no? Yung it's either vertical kapag halimbawa perpendicular sa surface o yung along dun sa link, yung direction natin. Then we have yung second category natin which is hinge or yung natawag nating pin, which restrict our structure to move on both the horizontal and vertical direction. So hindi tayo pwedeng mag-translate o mag-move back and forth or to the left or to the right, and also vertical movement or yung upward downward motion ng mismong um, section natin, anong member natin. Ang inaalaw lang niya is rotation. Okay? So, kaya dalawang unknown forces yung meron siya. Then we have the third one or yung nire-restrain natin fully yung tatlong tatlong conditions natin, support conditions natin, which are yung translation, yung horizontal, yung up and down, yung vertical natin, and then yung rotation natin or yung moment natin dun sa point na yon is also restricted. Kaya tatlong unknown forces yung kino-consider natin. Yan. So dapat sana by heart alam na natin yung number of unknown reactions kapag ganito yung support conditions natin, because we will use them in solving our beams. Okay? And we have different type of beams. Okay? So ito yung ilan sa tawag sa kanila. So depending on the type of support na meron siya, may iba't ibang tawag din siya. Okay? So yung first one, we have yung cantilever beam, yung cantilever, yung iba tawag nila, no? We have a cantilever beam na yung isang end niya is free or wala siyang support and the other end is fixed on that side. Okay? So cantilever yung tawag sa kanya. And then we have yung simply supported beam or meron tayong combination ng pair ng hinge or pin tsaka roller or statically determinate na beam. Okay? So, meron tayo ditong hinge, meron tayong roller. So, simple supported yung tawag sa kanya. And then we have overhanging beam or simply yung beam natin is um, meron siyang support between nung length niya pero may overhang siya either sa left side, sa right side, or both side niya. Okay, kaya overhanging beam yung tawag sa kanya. And then we have a continuous beam or kapag yung support natin is na greater than 2 na. Okay? So, continuous beam na siya. Okay? So, makita natin dito, we have 4 support, different support. So, meron tayong isang hinge and tatlong roller. So, continuous beam na yung tawag sa kanya. And we have fixed-ended beam wherein both ends are fixed on both sides. And then last is yung cantilever, simple supported beam. Or meron tayong fixed on one side and roller or hinge on the other side. Or minsan tinatawag to as prop beam. Okay? So bakit kailangan malaman yung yung tawag sa kanya? Kasi minsan pag word problem lang yung given and wala tayong given na figure, so tayo yung kailangan mag-analyze kung anong itsura ng beam natin. And kapag halimbawa, nakalagay doon sa statement ng problem, a cantilever beam, halimbawa carries gantong load, edi alam natin na magiging ganito yung support condition natin. Na fix lang siya on one end. Okay? And then, based from our discussion ng support reactions, dito natin ngayon i-apply yung knowledge ulit natin. Dito for the cantilever, alam natin na pag fix tayo, we have 3 unknown reactions. So, ayan. So, all directions are assumed. So, later, if ever upon assumption ng direction and mag-negative yung value natin, gagawin lang natin is i-reverse lang natin yung direction ng um, mismong assumed direction forces natin. Okay? Then dito for simply supported, we have a hinge which has 2 reactions and then a roller na merong 1. Okay? For overhanging, so this is a roller lang siya pero in reality this is unstable, no? Kasi pwedeng mag-translate horizontally yung structure natin pero without even siguro taking caution muna dun sa stability niya. Gusto lang natin pakita yung overhanging na ibig sabihin. Okay? Then dito sa kabila, continue. So we have 1, 2, 3, yeah. So we have 5 reactions. So statically indeterminate tayo to the second degree. Okay? So meaning kailangan natin ng compatibility equation na hindi pa natin magagamit at this point kasi hindi pa natin siya dinidiscuss. Okay? So dito sa fixed-ended, we have 3 on one side and another 3 on one side. Then for prop beam, we have 3 on one side and then 1 on one side or 2, depende kung hinge siya. Okay? So for type of beams na i-encounter natin for this lecture, it will be a cantilever one or a simple supported one. Okay? Kasi ito yung mga beams na determinate kapag chinek natin yung stability. Kasi 3 yung external stability niya, kung makikita natin, and wala naman siyang internal hinge, wala siyang internal support. So yung overall stability niya is statically determinate. Okay? So pag statically determinate, again, pwede natin gamitin yung tatlong equilibrium equations natin as follows, no? Okay? And to use these equations, meron tayong procedure for solving support reactions natin. And we can follow this one. Okay? So, ito daw yung steps recommended for solving a beam support reaction. Okay? First one is to draw daw yung free body diagram natin. Okay? So, Hopefully last time, napakita na natin to kung paano ginagawa. Pero yung free body diagram natin, kung halimbawa meron tayong beam structure, pwede tayong gumawa ng stick model lang, no? Stick equivalent, wherein doon naka-apply yung reaction forces na na-identify natin sa gantong condition or sa gantong scenario. Okay? The next is replace natin daw yung uniform distributed load, kung if any, with equivalent point load. So ano daw ba yung equivalent point load na yan? So, meron kasi tayong iba't ibang type ng loadings, and then meron kasi siyang iba't ibang form o iba't ibang conditions wherein pwede natin siya i-convert into its equivalent point load o tinatawag natin equivalent concentrated load. Okay? Or ECL na tinatawag sa ibang book, no? So, yan yung kailangan natin munang i-discuss. So, punta muna natin tong common loading type. So, ito daw yung mga iba't ibang loading types na present sa isang structure. So, we have a point load. Okay? So, point load, ibig sabihin, from a certain point, may naka-act na concentrated load sa kanya. Okay? May nakapatong na load, kaya point load siya. And yung equivalent force at load centroid niya o yung ECL niya is also a point load lang din kasi nga point load na siya. Hindi na siya mako-convert into other form kasi naka-point load. Ano na siya? Concentrated na yung force natin. Okay? And then, this is pertaining dito sa support na to, yung distance niya from the support, tawagin natin letter A. Usually, ang naming ng support is from left to right. So, usually, this will be A, this will be B. So, ito sa support A, support B. And from support A, ang distance ng concentrated load natin is A. Yun ang ibig sabihin niya. Okay? Next, we have uniformly distributed load. So, ito yung klase ng load na yun na I hope by this time medyo familiar tayo kasi ito yung sinold natin dun sa first lecture natin regarding sa loadings natin, no? Yung sa calculation ng dead load. So, ito is naka-apply siya do sa whole length ng structure natin. And pwede daw natin siyang i-convert sa equivalent force load niya, sa constant ACL niya. So, mako-convert mo siya, magiging siyang W times L. Yung W niya is ito, and yung L niya is yung length niya between dun sa support natin. So, in converting itong uniformly distributed load, para hindi na kayo mag-memorize ng formula, ang tatandaan nyo na lang, yung itsura ng uniformly distributed load is a rectangle. And all you need to do is to remember yung area ng rectangle. Ano ba ang area ng rectangle? Area ng rectangle is base times height. Di ba? Ito yung base, ito yung height niya. So, based from this figure, ang height natin is yung W. Okay? And yung base niya is yung L. So, yung area niya will be equals to base times height or WL, which is the same as this one. Okay? And naka-apply siya dun sa centroid niya, sa gitna niya, sa kalahati niya. Okay? Kaya L over 2. Okay? Kaya nakalagay dyan, effective force at load centroid. Okay? Sa centroid ng loading natin. Halimbawa, ito lang yung uniformly distributed natin, hanggang dyan lang siya. Hanggang sa L over 2 lang. Okay? So, ibig sabihin, pag kukunin natin yung equivalent niya, yung mismong ano natin, ECL natin, dito siya naka-apply. Sa gitna lang nung kung saan siya merong uniformly distributed load. Okay? So, dito yun. Okay? And magiging distance niya will be kalahati ng L over 2, which is L over 4. Okay? So, depende kung hanggang saan. Kung halimbawa, hanggang dito sa portion na to, yung ating uniformly distributed load, yung kanyang ECL will be do sa centroid noon. And whatever tong length na to, yung half nun, yung location niya mula dun sa point na yan. Okay? Next, we have a triangular distributed load. So, a triangular distributed load is meron tayong maximum value at one end and nagdi-decrease siya as we go dun sa other end hanggang maging 0. Okay? So, in triangular loading, same as dun sa ating conversion kanina or discussion, kapag meron tayong triangular loading, tandaan na lang natin is yung area ng triangle. Okay? Ano, ang area ng triangle is 1/2 base times height. Okay? So, ang base natin, again, is yung L, yung height natin is yung W. That is 1/2 L times W, or the same as this one, WL/2. Okay? And yung application niya is sa centroid ng mismong triangle natin. Ang centroid ng triangle, and bakit yung triangle natin? Yung centroid niya is, ayan po yung location niya. Okay? So, itong location na yan ay L/3 ang basa dyan, or ang value niyan. Tapos ito is 2L/3. Okay? So, ibig sabihin, laging L/3 yung centroid niya. So, kung halimbawa mabaliktad yung condition ng triangle natin, naging ganyan siya. Okay? So, pag kinuha natin yung centroid, kapag nandito sa point A, ano yung value nito ngayon? So, syempre, yung remaining dun sa length natin. Kung 1/3 ito, kung L/3 ito, yung remaining natin is 2L/3, which is ito. Okay? So, mula dito, 2L/3 na siya. Okay? And then, next, we have yung trapezoidal o trapezoidally distributed load, wherein yung ECL niya, yung equivalent loading niya, is nakukuha pa rin sa area din naman ng trapezoid. No? So, meron tayong H1, H2, tapos base. So, area ng trapezoid is 1/2 ng summation ng height niya, yung base niya, no? Kasi minsan, di ba, base yung ang definition ng trapezoid is may parallel base, no? Pero parang inorient lang natin ng iba ng 90 degrees yung trapezoid natin. Times B. For dito, ibig sabihin nito is W1, W2, ito yung length natin. So 1/2 W1 plus W2 times yung length natin, which is equivalent nito. Okay? So WA ibig sabihin yung data, yung value lang niya dito at point A at point B. Pero may mas madali siyang na hindi niyo na kailangan i-memorize to kasi mahirap tong i-memorize yung length, yung distance niya. Okay? Since trapezoid yan, pwede tayong mag-divide ng section natin. Ito is pwede natin i-divide sa two portion. Yung two portion natin is meron siyang rectangle na part, meron siyang triangular na part. Okay? So, ibig sabihin, halimbawa, ito yung rectangular portion niya. Okay? So, ito yung magiging WB natin. Okay? Kung WB to, ibig sabihin nito, iba na yung, ano nito, iba na yung height niya. That will be WA minus WB. Okay? So, kapag ganyan yung cases natin, pwedeng gawin natin yung ECL ng triangular, ilalagay natin ganyan, and yung ECL ng rectangle. So, may dalawa tayong ECL na equivalent nung load type na trapezoidal natin dito. Tapos, identify na lang natin yung distances based from the previous distances na meron tayo dito. Okay? So, I would suggest kung wag nyo nang memorize to. Okay? I-divide nyo lang siya into two load types, which are yung rectangular and triangular loading natin. Okay? Pero if you feel confident dito sa values na to or hindi kayo malilito, okay lang din naman. Okay? Kasi pag halimbawa iniisip ko kasi maging ganito lang yung itsura ng trapezoid. Ayan. Hindi siya fully dun sa beam natin. So paano mo ngayon ka-calculate yung distance na ito? Okay? So baka malito ka na. So kung halimbawa naka-rectangle siya tapos naka-triangle ka, alam mo na ito may distance siyang L/3 dito, tapos plus mo lang kung ano yung remaining dito para makuha mo yung total distance mula dito. Okay? Ayan. And then we have the last one, yung point moment load. So, point moment, ibig sabihin, naka-apply siya sa isang particular point dun sa mismong along the beam natin. Pero kapag kinukuha natin yung moment ng moment, hindi na natin kailangan siyang i-multiply by the distance itself. Okay? So, kasi nga, di ba, as a review na din, alam natin na si moment is equals to force times distance. And itong distance nito, dapat siya ay perpendicular dun sa direction natin. So, ibig sabihin, kung halimbawa itong hinge natin dito, meron tayong vertical tsaka horizontal niya, no? Yung horizontal will be 0 kasi along siya nung point natin. Okay, dito. Halimbawa, kunin natin yung moment dito at this point. Okay? So, para makuha yung moment niyan, kailangan mo ng perpendicular distance. Eh, vertical yung load natin. Ano bang perpendicular sa vertical? Eh, di horizontal. So, ano yun? Ito yung horizontal distance na yun. Ito yung D na tinatawag natin sa formula natin. So, kailangan laging horizontal yung distance. Ngayon, si horizontal load is along dito sa length niya. Ano yung perpendicular ka horizontal? Vertical. Okay? Pero wala siyang vertical distance kasi along siya dun sa line of action nitong mismong to. Okay? Not unless, halimbawa, naka-apply dito yung horizontal natin. So, may distance siyang Y dito. So, pwede siyang mag-rotate. Pero pag wala siyang distance, wala tayong moment or rotation sa kanya. Okay? So, ito po yung mga common loading natin. And, ayan. So, ang trick lang is to be familiarized with them. And dito sa structural analysis, pwedeng mag-combine yung mga yan. So, pwedeng magsama-sama si trapezoidal, tapos may moment, meron ding concentrated load, yung tatawag natin point load. So, bakit nagkakameron ng ganun? Kasi pag kumukuha tayo ng mga tributary areas, 'di ba, ng beam natin, halimbawa, nagkakameron ng transfer ng loading yung portion na kinakarga niya. So, let's say meron tayong ito yung column natin. Okay? So, natin column yan. Then we have yung girders natin. Okay? And then meron tayong secondary beam. O yung beam natin. Di ba si beam na to, tawagin natin AB, tawagin ko tong CD, yung girder natin. Si AB is meron siyang tributary na to. Okay? Na nakalculate natin before yung sample. Makakalculate natin. So, pwedeng pag inano natin, visualize natin si AB, pwede siyang maging simple supported, no? Okay? So, pwedeng halimbawa, meron siyang uniformly distributed load. Okay? And then, makukuha natin yung reaction niya. So, ito yung RAY para sa vertical, kaya Y. RAX para sa horizontal. Tapos ito, RBY. Okay? Ibig sabihin, si A, di ba nakapatong siya dito sa girder na to, girder CD. Pag tinignan natin yung girder CD, so si girder CD, sabihin natin, nakafix naman siya dun sa column natin. Okay? So, ito si C, ito si D. Okay? So, dun sa along its length niya, dun nakapatong si A. So, yung support reaction ni A, itong support reaction niya, pupunta yun dito sa gitna niya. Okay? So, bukod doon sa kinakarga niyang tributary, ito yung tributary kinakarga niya. Okay? So, kaya halimbawa kung two-way yung mismong ano natin, no? Pwede siyang maging trapezoidal, depende sa size, or pwede siyang maging triangular yung loading niya. Okay? Pero halimbawa, sabihin natin rectangular lang yung loading ni CB wala doon sa tributary niya. Okay? So, ito yon. And then, yung reaction mismo ni beam AB, ililipat niya yun kay girder. Okay? So, dito mag-a-act yun as concentrated load. Kung may value ito yung A natin. Horizontal tsaka vertical natin. Ito yung RBY natin and RBX natin. RAY tsaka RAX. So, dito nagkameron na siya ng combination ng loading. Kaya sinasabi ko itong mga loading type natin, possible siyang mag-combine talaga ng value. Okay? O pwedeng applied sila sa isang beam lahat. Okay? So before we proceed, meron ba tayong clarification dun sa loading types natin? If none, kahit thumbs up lang to verify. Okay? Thank you. So, ayan. So, now we can calculate some examples using this formulas na diniscuss natin. Okay? Para i-identify natin yung support reaction ng given beam natin. So, let's start with the first one. Okay? So, let's solve for the support reactions of the given beam. So, ito yung given beam natin. We have what type of beam? What type of beam kaya ito? So, we
Simply
have,
supported.
okay, so it's simply supported, correct? Kasi meron tayong hinge on one side, okay, hinge, and then meron tayong roller sa kanya, okay? And ano ba yung sabi sa ano natin, sa step natin? So, copy natin tong step natin. First thing na gagawin natin is to draw the free body diagram nung mismong ano natin, okay? Nung beam natin. Yun yung gagawin natin muna. Okay? So, baga yung idealized structure natin. Natin. So, dito ko na nalagay ito sa taas. Para may guide lang tayo. Okay? So, now we can now draw yung ano natin. Yung ating free body diagram. So, assume natin na ito yung beam. Ito yung beam natin. Okay? And then, yung vertical natin, okay? So, dito meron tayong applied load na 15. Yung support muna tayo. So, dito sa roller at B, meron tayong vertical. Tawagin kong RBY. Then, for our hinge, meron tayong vertical. Then, meron din tayong horizontal sa kanya. So, RAY and RAX. Okay? And then, we also have our support, our applied loads. So, meron tayo ditong applied load na 15 kilonewtons. Okay? And also 10 kilonewtons. Okay? And then yung distances natin, ilagay ko na lang yung distances. So, meron tayong 1.5 meters. Dito, this will be 3 meters. And then this will be 1.5 meters. Okay? So, ano ba yung total niyan? So, that is a total of 6 meters dito sa overall length natin. Okay? Next is i-replace natin with the ECL, yung ating load. Pero since point load na siya, hindi na natin kailangan mag-convert into equivalent concentrated load. Okay? Next is solve down natin using yung summation of MA. Okay? Pero although itong mga to, hindi to golden rule na dapat lagi yung step. Basta ang kailangan natin satisfy is yung tatlong equation natin of equilibrium. Okay? Kasi this is a determinate structure. Ito lang yung kailangan natin satisfy. Okay? So, ayan. So, anong goal? Kailangan natin ma-identify di ba yung mga forces natin. And to achieve that, kailangan gamitin natin itong equations na to. So, ang pwede natin gawin, si moment, halimbawa muna yung unahin ko, saan ka kayo pwede mag-moment para ma-eliminate yung dalawang unknowns para yung isa is malaman natin. Tingnan natin, pag dito sa B, pag sinabi ng summation of moment, lahat ng forces natin, i-rotate natin papunta dun sa point na yun. Ibig sabihin si 15, magro-rotate siya papunta doon. Si 10, magro-rotate siya papunta doon. Si RAY, magro-rotate papunta doon. Si RAX, magro-rotate ba siya? So si RAX is along dito sa line of action ng point natin. So kailangan natin ng perpendicular distance para magkameron ng rotation. Pero since pareha sila ng line of action, walang rotation si RAX. Meaning, pag ni-rotate natin yung forces natin, si RBY, wala din siya kasi nandun siya sa point na yun. Ano magiging unknown natin? Ilan? Magiging unknown natin is isa na lang, si RAY lang. Okay? So, pwedeng unahin natin is summation of moment at B equals to 0. Kasi isa lang yung matitirang unknown. Pero dito sa procedure natin, summation of moment at A ang una niya. So, ang gusto ko lang i-point out, hindi golden rule na dapat A lagi yung uunahin natin. Pwedeng tingnan natin kung saan magiging isa lang yung reaction na unknown para ma-solve natin siya upon calculation. So kung halimbawa at A naman yung rotation natin, alam natin na kung dalawang unknown natin will be 0. So automatic, isa lang yung unknown na matitira. So makukuha agad natin yung value. So pwedeng summation of moment at A na agad yung unahin natin. Kasi may mga conditions, halimbawa si RAX, pwede halimbawa applied siya at a certain distance. Kunyari, no? Halimbawa meron siyang external load, halimbawa may wind. Halimbawa applied siya at 1 meter nung distance na yun. Halimbawa nasa roofing tayo. Halimbawa sabihin natin may parapet siya doon. Okay? So, halimbawa meron siyang loading doon. So ibig sabihin kung meron siyang perpendicular distance sa 1 meter, magro-rotate na siya dito. Okay? Kaya mas safe i-assume na dito tayo mag-moment na una. Okay? So, summation of moment at A is equals to 0. Okay? So, paano ngayon yung rotation? Pwede ka mag-assume ng rotation. Counterclockwise o clockwise. Pero kung I'm using kung ano yung rotation ng applied loading. So, yung applied loading natin is 10 tsaka yung 15. Ang rotation niya, pagka pupunta siya kay A, is pag ganun yung rotation niya. Okay? Pa-clockwise. So, para hindi ako malito, yun yung ginagawa kong rotation as positive. Okay? Pero pwedeng kayo mag-assume, pwedeng counterclockwise yung gawin yung positive. Depende sa diskarte ninyo. Okay? So, summation of moment tayo. So, yung moment ng 10 kilonewton. And then, ano yung distance niya from point A? 1.5. Then next, we have yung 15 kilonewtons. Ano yung total distance natin? We have 3.0 plus 1.5 meters. Okay? Ito po yun. Kasi ito yung tatravel niya mula papunta kay A. Ito yung i-rotate niya papunta doon. Ibig sabihin, no? Yun yung perpendicular distance niya mula doon sa point na pinagro-rotate natin. Okay? Next is yung RBY. Si RBY, ang rotation niya is counterclockwise na siya. Okay? Ibig sabihin, negative na siya. Kasi assumption natin is positive ang clockwise. RBY, and then, anong distance natin? So, yung total distance nung between support natin, which is 6 meters. Okay? So, wala na tayong ibang force na pwede rotate. Si RAX and RAY, again, cannot be rotated kasi wala silang perpendicular distance. Okay? Equals to 0. Then, simplify lang natin to. Combine natin yung itong force na to kasi ano siya? So, 10 times 1.5 plus 15 times 3 plus 1.5. That is 82.5 kilonewton meter. Okay? And this will be 6.0 meter RBY is equals to 0. So to solve this, transpose lang natin to the other side. Okay? So 82.5 kilonewton meter is equals to 6.0 meters RBY. And then to isolate yung RBY, divide natin both side by 6.0 meters. Okay? So cancel out to. Mag-cancel out yung meters. Therefore, yung RBY natin will be, anong unit niya? Ang unit niya will be, yung matira is kilonewton. Yung value niya will be 82.5 divide natin ng 6. That is 13.75 kilonewtons. Okay? So this is our initial value pa lang. Okay? Hindi pa natin alam kung tama siya. Pero since positive yung lumabas na value, sabihin yung assumption natin na siya ay upward dito, is considered correct na upward dapat yung reaction niya, yung force niya. Okay? Ngayon, hindi natin sure kung tama yung value niya, pero alam natin yung direction niya tama. Okay? Next. Meron na tayo ngayon summation of moment. Okay? Pwede ngayon natin gawin is yung summation of Fx naman is equals to 0. And referring to sa free body diagram natin, ang horizontal natin is Rax lang. Wala nang iba. So, this will be Rax is equals to 0. So, ito yung second reaction natin. Okay? And then, we can do is yung mag-moment ulit tayo pero sa kabilang reaction naman. Okay? So, as nakasabi na din dito. Okay? Okay? Yan. So, ngayon, magmo-moment tayo at B. So, ano yung susundin kong direction? Again, you can assume any direction. Pero ako, base ko dun sa loading natin. So, ito yung loading natin. Going to B will be counterclockwise. So, assume ko to na counterclockwise is positive. So, lagay natin yung loadings. 15 kilonewton times 1.5 meters plus 10 kilonewton times 3.0 meters plus 1.5 meters. So ito pinaghihiwalay ko lang pero pwede niyo na ilagay agad na 4.5 siya, no? So I'm just showing this for clarity lang and demonstration ng paglagay ng total distance natin. Okay? And then ano pa, pwede mag-rotate kay B. Si RAX 0, hindi siya mag-rotate. Si RBY nandun sa point na yun, hindi mag-rotate. Si RAY na lang, which is ang rotation niya is clockwise. Okay? Which is opposing our assumed direction. So minus RAY times 6.0 meters is equals to 0. So ngayon, combine ulit natin to. So 15 times 1.5 plus 10 times 3 plus 1.5. That is 67.5 kilonewton meter. Okay? Minus 6.0 meter RAY equals to 0. So sa transpose lang ulit natin to from to the other side. So 67.5 kilonewton meter equals to 6.0 meter RAY. So divide ulit natin by 6.0 meter. We have a value of RAY, cancel yung meter, is equals to 67.5 divided 6, that is 11.25 kilonewton. Okay? So this is our initial value for RAY. Okay? So ngayon, meron na tayong value ng tatlong unknown reactions natin. What to do now is to use yung remaining na equilibrium equation natin, which is yung summation of Fy. As pang check natin. Okay? Assume ko na summation of Fy is equals to taking positive as upward as positive. So yung lahat ng upward ay positive. So si RAY and RBY will be positive. Tapos negative si 10 tsaka si 15. So that will be RAY plus RBY minus 10 minus 15 is equals to 0. Substitute natin yung na-calculate natin RAY, RBY. So RAY is 11.25 plus 13.75 minus 10 minus 15 is equals to 0. And when you calculate it, that will be equal to 0. So, okay yung value natin. So therefore, yung calculated values natin ng reactions are indeed the values of our support reaction. So this will be our final answer. Okay? So kung if halimbawa, upon checking, hindi nag-0 to dito. So meaning meron tayong mali dun sa calculation natin and we need to recheck and re-evaluate yung mismong calculation natin. Baka mamaya may mali tayong pindot sa calcu kaya na iba yung value. Pero lagi tayong may way to check yung ating forces if it will be in equilibrium. Okay? So this is for example number 1. Question po for example number 1. Okay, so is the silence means naintindihan or okay? So, okay. So, thank you. So, kasi ito parang review na lang din ng statics natin, no? So, hopefully, nare-recall yung statics. Pero ngayon, we are um, solving talaga yung support reactions natin. Okay? And I'm reiterating yung process one by one para mas nasusundan ng lahat. Okay? Kasi may iba't ibang loading conditions na tayo. Next, we have the second example. We have what type of support dito? O what type of beam yung meron tayo ngayon?
Triangular, sir.
Yung loading natin is triangular, yes. Pero yung type of beam natin,
Cantilever.
okay. So cantilever, yes. Fixed beam tayo sa isang end, ibig sabihin, no? So, following our said step, no? So, drawing lang natin yung free body diagram natin. So, ayan. Ito yung support natin. Then, we have a triangular load. Then, drawing natin yung reactions natin. So, reactions natin is end lang. So, we have here vertical, horizontal, and moment. So, tawag ko itong RAY kasi ito yung point A o yung tawag sa kanya, no? Ito is point B. Okay? So, dito, may nakita kayong point. Hindi ibig sabihin internal head siya, no? Unless in the future na ano natin, na discussions, unless na naka-note siya na internal head siya. Tsaka mo lang siya i-assume na internal hinge. Ngayon, itong point na to is just arbitrary to designate na yung point na yon pwede nating tawagin as point C. Okay? Pero it doesn't mean na siya ay internal hinge. Pag gantong yung beam natin, makikita mo internal hinge siya kapag halimbawa nakaganon siya. Okay? Bawa ito yung beam natin. Tapos parang may connection siya ganyan. Ganun yung internal hinge natin. O kaya nakalagay sa kanya, hinge. Kaya mayroon siya nakalagay na pin. Okay? Pero ngayon, arbitrary lang yung point natin na yan. So, ngayon, determinate pa din yung structure natin. Okay? Kasi baka mamaya mag-question, bakit hindi kinonsider yung internal hinge natin. Okay? Ayan. So, ngayon, triangular ngayon yung load natin. And according dun sa ating guide for loading, pag triangular yung load natin, kailangan yung ECL natin is dun sa kanyang centroid nag-act. So, ito yung centroid niya. Okay? And yung value ng ECL natin, o ECL natin, makakalculate natin as area ng triangle natin. So, area is 1/2 W times L lang. So, that will be 1/2 tapos 1,200 Newton meter. Multiply natin ng ilan yung total natin? 3 meters. Okay? Cancel yung meter. We have 1,200 times 3 divide 2. So, 1,800 newtons. Okay? As our ACL. And then yung location natin from the diagram is ito is L over 3. Okay? So, yung L over 3 natin, dito ko na lang lalagay. So, 3.0 divide 3, that is 1 meter. So, ibig sabihin ito is 1 meter. So, ibig sabihin itong remaining natin, kung 1 meter yun, 3 meters yung total, 2.0 meter to. Okay? Now, kompleto na yung free body diagram natin. Na-convert na natin into reactions, yung of concentrated load. Pwede na natin gamitin si moment at A is equals to 0. Bakit kay A? Para ma-eliminate ulit yung dalawang unknown, ang matitirang unknown is si moment. Okay? Again, si moment, hindi niya kailangan ng distance para mag-rotate. Kahit saan siya nakalagay, kahit doon sa mismong point, kapag may moment tayo, pwede siyang mag-cause ng rotation doon. Okay? So, lagi siyang present. Okay, so dito, yung loading natin is ito. So, papunta siya doon. So, clockwise direction tayo. Okay? So, clockwise is positive. So, yung loading natin, how much? 1,800 Newton times yung distance natin, which is 1.0 meters. And then, anong kasunod na? Walang RAY, walang RAX. Moment na tayo. Ang moment natin sa A is counterclockwise ang direction. So, negative MA is equals to 0. So, gagawin mo lang, transpose mo lang to the right side. Makukuha mo na agad yung value ng MA, which is 1,800 Newton meter. So, this is our initial value of MA. Next, summation of Fx is equals to 0. Fx natin is RAX and wala na, no? Walang other force na horizontal. So, RAX is equals to 0. Okay? Next, yung B natin. Okay? Yung summation at B. Yung summation at B, ito magro-rotate doon. RAY magro-rotate doon. Si RAX hindi kasi line of action niya. Wala siyang perpendicular distance. Si moment is magro-rotate siya papunta doon. Okay? So, si RAY lang yung unknown. So, pwede natin summation of moment at B. Taking, pwedeng clockwise as positive. Okay? Kasi ito is, counterclockwise, sorry. Counterclockwise yung rotation niya. So, 1,800 Newton times 2 meters kasi yun yung remaining distance. And then, yung moment natin is, anong direction ng moment natin? Counterclockwise din. Okay? So, plus yung moment natin, plus yung RAY natin, which is clockwise na yung direction niya. So, opposing siya ng direction natin. So, hindi dapat plus. Dapat siya ay minus. Minus RAY times yung total distance natin na 3 meters. Equals to 0. So, substitute natin yung value. 1/8 newtons times 2 meters. Yung MA natin, calculated as 1/8. Minus, o transpose ko na sa kabila, 3.0 meters RAY. Okay? And dividing both sides by 3.0 meters. 3.0 meters. Cancel. Ka-cancel yung meters dito. So, RAY natin is equals to 1/8 times 2 plus 1/8. Divide natin sa 3. We have RAY as 1,800 newtons. Okay, so this is our value for RAY. Then to check is just maximize lang natin yung equations natin. So lahat ng vertical natin taking upward as positive. Vertical natin is RAY tsaka ito lang ACL natin. Okay, so RAY minus yung 1,800 natin equals to 0. So, 1,800 newtons, yung value na calculate natin, minus 1,800 newtons. So, indeed, this is in equilibrium. Therefore, yung values calculated for RAY, MA, and RAX are all correct. Okay? So, ito na yung magiging values ng reactions natin. Okay? Question for example number 2. Okay? So, ayan. Okay. So, let's proceed with another example. Okay? So, ngayon, ayan, isagarin na natin. Meron tayong fixed beam, meron tayong rectangular load, meron tayong triangular load, meron tayong point load, meron tayong moment na load. Okay? Yan. So, sagad na natin. So, ngayon, pinapanap yung support reaction natin. Support reaction natin will be on what side lang? Kay A lang, di ba? Kasi yun lang yung nakafix natin. So, first condition natin is to, again, draw our free body diagram. Okay? So, our free body diagram will be like this. Okay, naka-fix dito. Then we have a rectangular load. And then meron tayong triangle. Okay, so yeah. Then Ito yung unknowns natin. So we have RAY, RAX, and MA. Then applied loads natin, ano ba ito ay? So, at pantayan na, pantay. Okay, so dito meron tayong applied na 70. Okay, 70 kilonewtons. And then meron din tayong applied moment na 150 kilonewton meter. Okay, so this is point A. So assume natin na point B. Okay, then meron tayong rectangular, so meron siyang ECL. Meron tayong triangular, meron siyang ECL. Okay, so calculate natin yung ECL natin. So for triangular, that will be weight times length lang. Okay? So yung weight natin is 30 kilonewton meter. And ano yung length ng rectangle natin? Dito. Length niya is kung hanggang saan lang siya rectangle. So dito lang, no? So 4 meters lang. Okay? 4 meters. So cancel out natin. We have 120 kilonewton. Okay? Then for our triangular loading, we have 1/2 ng WL. That is 1/2 ng 30 kilonewton per meter times ano yung length ngayon ng triangular natin. So yung length ng triangular natin is base lang dito. Ito lang yung triangular natin. Okay? So that is 2 meters. Okay? So cancel yung meter. So cancel yung 2. So our ECL for that is still 30 kilonewton. Okay? So this will be 120 kilonewton. Then this is 30 kilonewton. Okay? Ngayon, ang kakalculate naman natin is yung mga distances natin para alam natin yung mga moment distances natin. Okay? Okay, dito, since sa centroid to nung rectangular natin, yung rectangle natin is ito, this will be magkano? So 2.0. 2.0. Okay? And itong portion na to is L over 3. Okay? So, ano bang value ng L over 3 natin? So, L over 3 is equals to 2.0 over 3 or 2/3 tayo dito. Okay? So, this is 2/3. Then, yung last natin is 2L over 3. 2L over 3 for 2 times 2 over 3 or 4/3. Or this will be 4/3. Okay? So, yan yung mga distances ng mismong applied ECL natin dun sa support natin. Okay? Now na na-simplify na natin yung mismong structure natin, pwede na natin gamitin ulit si equilibrium equation. Starting with summation of moment A na lang muna ulit. Okay? Kasi doon natin ma-eliminate yung dalawang unknown forces natin which are yung RAX and RAY. Then yung rotation natin, assume ko as clockwise as positive kasi si 120 papunta doon will be clockwise, 30 clockwise, si 70 clockwise. Si 150 counterclockwise siya. Si RAX and RAY are 0. Then si moment will be counterclockwise din. Okay? So, clockwise direction ng positive natin. So, this will be 120 kilonewton times 2.0 meter plus 30 kilonewton times 4 meters plus yung 2/3 natin. Okay? Plus 70 kilonewtons times yung total natin, 6.0 meters. Then, yung ating moment is counterclockwise, so minus 150 kilonewton meter. Let me move lang this one. Okay, and then yung MA natin is counterclockwise, so equals to 0. So, pwede i-combine lang natin lahat ng values na to and then si MA transpose natin sa kabila. Okay? So, magkakaroon tayo ng value na MA is equals to, upon calculation, 120 times 2 plus 30 times 4 plus 2/3 plus 70 times 6 minus 150. So that is 650. Unit is kilonewton meter kasi yan ay moment. Okay? Next, summation of Fx. So dito ko na lang sa taas talagay. Summation of Fx is equals to 0. So Fx natin is Rax lang. So wala tayong ibang value. So ito na yung magiging value natin for Rax. Okay? Next, summation of moment at B. Summation of moment at B equals to 0. Taking, so yung forces natin, counterclockwise, yung positive niya. Okay? So, counterclockwise is positive. So, apply natin yung moment natin. So, we have 120 kilonewton times ilan yung distance natin. So, that will be 6 yung total. So, minus 2. So, 4 lang yung distance niya. So, 4.0 meter. Plus 30 kilonewton. Yung 30 kilonewton natin nakalagay naman na 4 over 3 siya. So 4 over 3 meters. Yung 70 hindi magro-rotate kasi nandito siya mismo sa point na yon. Pero yung moment, sabi ko nga, magro-rotate yan kahit nandun siya sa point. So we have plus 150. And then si MA, na-calculate natin kanina, is also counterclockwise. So plus MA. Okay. And then, ang reverse lang ang rotation ay si RA, which is clockwise siya. So, minus RAY times yung total distance natin is equals to 0. Okay? Pwede na natin combine to. No? Pwede natin gamitin yung value ni MA. Tapos, transpose natin sa kabila si RAY. Okay? So, this will be 120 times 4 plus 30 times 4/3 plus 150 plus 650. Total is 1,320 kilonewton meter is equals to 6.0 meter RAY. Okay? So, divide natin both side by 6.0 meter. Cancel. So, we have RAY. So, 1,320 divide 6, that is 220 kilonewton yung value ng RAY natin. Okay? So, to finalize, we have to check with the last equilibrium equation. So, taking upward as positive. So, vertical reaction natin is RAY, 120, 30, tsaka 70. So, we have RAY minus 120 minus 30 minus 70 is equals to 0. So, 220 minus 120 minus 30 minus 70 is equals to 0. So, this is equal to 0, which tells us that the calculated reactions natin for RAX, RAY, and MA are all correct. Okay? So, ganyan po ang pag-solve ng support reactions natin. Okay? Question po?
Sir, what if pag nagkabali-baliktad po yung assumption ng ating rotation?
Rotation. So, dapat consistent ka. Kung halimbawa, clockwise ka sa, halimbawa dito, sa una pa lang, counterclockwise yung rotation mo. So, dapat yung 120 mo will be negative, tapos to negative, tapos ito will be negative pa din, ito positive. So, mangyayari, yung lalabas mo na MA, will be 650 pa din. Kasi this will be positive na. This will be positive naman. So, ito yung itatranspose mo ngayon sa kabila. So, makukuha mo kasi dito, pag sinam mo, gagawin mo tong negative, 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 tapos ito ay positive. Kasi mali, iba yung value mo, o yung assumption mo kasi mas madami yung negative dito. So, itong negative value na makakalculate mo dito, negative 650 yon. Pag tinranspose mo, that will be positive 650 pa din. So, parehas pa din ang sagot. Kaya nga, no matter kung ano yung assumption mo, basta yung mag-stick ka dun sa assumption mo. Kung halimbawa, mas nandadalian ka na lahat ng assumption mo clockwise lang, kahit anong direction, basta clockwise lang para hindi na paiba-iba yung moment natin. Okay lang din. As long as kapag nag-negative yung value niya, ano ba ito, naging negative yung value niya dito. Ibig sabihin yung assumption ko na pataas siya, mali. Na later dapat kapag isasagot mo na siya, dapat downward siya, no? Talagyan mo na lang siya dito na downward siya. Kaya kung sa choices, kung multiple choice siya, dapat negative 220 yung sagot mo. To signify na dapat downward yung direction ng reaction mo dun sa force natin. Okay? Did I answer your question? Okay. Ayan. So, if no more question, our next topic will be about dito sa internal force. Pero our time will not permit a discussion of this internal force na. Kaya I will post na lang a additional lecture for this one, internal force. Pero yung example na gagamitin dito for internal force will be the same example dito sa tatlo. Itong tatlo yung gagamitin natin. So dito kaya may mga points dyan. Diyan natin hanapin yung mga internal forces, no? Dito. So, mag-post na lang ako ng lecture video kasi that will also be included in your examination. So, um, dahil short na tayo sa time, i-post ko na lang. Hanggang latest will be on the weekend yung force, yung mismong discussion ng internal force. Okay? Pero for now, if you don't have any more question regarding sa pag-identify ng support reactions natin, this ends our lecture for today. Okay?
Okay, sir. Thank you, thank you.
Salamat po, sir.